Hey, what's good, YouTube? It's Brian Jenkins here. I'm a data scientist, and I'm going to be teaching you guys about pandas today. So if you ever have had to analyze a CSV or a set of tabular data in Python, and you've had to read it in, it can be kind of a pain if you're not using pandas or something like that. So we're going to talk about that. We're going to talk about reading it in, talking about if you have your own data and you want to just make your own data frame from memory, we can do that too. Or you can make a series from that, that's fine as well. But without spoiling too much of the video, I'm just going to go over down that way, wherever that corner is. That's where my little face is going to be. And then my code's going to be over here, and you guys can follow along with it. I'll provide a link to the data that I used in this video in the description, and I hope you guys enjoy. Okay, so if I want to start working with pandas, the first thing I have to do is import it. So we're going to do it like this. Import pandas as PD, and then we're also going to use NumPy, but just a teeny tiny bit. That'll be a little bit later. Okay, so now that I've got my libraries imported, let's get some data to work with. So let's say we have data on 7 guys whose favorite colors and numbers were given as follows. So we got Timmy, Jimmy, Ed, Ned, Fred, Jed, and Ted. Are there any more Eds I can rhyme with there? I don't think so. And then I've got colors: red, blue, green, red, yellow, orange, blue, etc. And the numbers there too. So now we've got 3 different types of data for them, so we should be able to manipulate this. Okay, so now we can actually define our data frame now that we've got our data. So here's kind of the general structure of how I like to do it, at least. So I like to put it in as a dictionary, to where you've got the name of the column followed by the column itself, and then repeat that for however many columns you have. So in this case it would just be name, we'll call it that, followed by the column. Similarly, we'll call the colors color and the numbers number. And then we'll run it. And then let's take a look at what this actually looks like. So this is kind of the structure we're going for here. We've got our name column, our color column, our number column, and we've got these indices here on the far left here, 0 through 6. And we've got our header up here on the top. And if we want to access what's in that header, we can just do df.columns, and we get that. But if we don't want it in this weird type of format, we can just put .toList, and it comes out as a list. Similarly, we can do the same thing for the indices on the far left. And you get 0 through 6. Now if I don't do toList here, what you'll see is the same thing, but it's just expressed in a different way. Alright, so now we know how to access the headers and the indices themselves, but let's see how to get the columns and rows that they represent. So let's do the name column here. So if you just put the data frame followed by brackets, and then the inside the brackets the name of the column you want, you get the column. Similarly, you can do the same thing for the color. And then if we want the row, we specify which index we want. Let's do the first one. And there you go. So see index 1 here, so Jimmy, blue, and 25, and then those right there. And then you can also do multiple columns and multiple rows. The key difference here is we're going to be using double brackets here. So df color name, and you'll notice you can change up the order too. So name and color were in this order here, but whatever order you specify when you call it here is going to be how it comes out. So you can also do number and name. There you go. You can do the same thing with the indices as well. Very similar process. 1, 3, we can do 5, 4, however you want to do it. And in a data frame, typically when you load it in, you're going to want to see what the first few rows look like, just to inspect it. So df.head will give you that. So first k amount of rows that you want. I just chose 4 here. You can do 3 if you want. And similarly, what if I want to look at the last few rows? So that'll be tail. Let's do the last 2. Okay. And then there's going to be a time when you want to iterate through the rows of a data frame at some point. I'm personally not a big fan of this method, but I mean, it's got its use cases. So the way you have to do it looks a little unintuitive at first, but it kind of makes sense. So what happens is you call df.iterRows, and that's going to give you both an index and a row, so you have to make sure you put both of those in there. And let's just print each of these. And here at the end of this print statement, I'm actually going to end this with a tab because I want to keep them all on the same line, else it'll look kind of weird. So if I do it just like this, then it still looks a little off, right? Because what it does is it gives you the row itself. It doesn't actually give you the values of the row just by themselves. So if we want to do something like that, it looks a little neater. But I mean, there might be a use case for you wanting to pull out the entire series there with this one-to-one correlation with name Timmy, color red, number 100. You may need that for some reason, so I just wanted to show you both ways to do that. But for now, let's go back to this. And then just another example here. So when you're referencing the row in df.iterRows, if you want to reference a specific column that your row is associated with, you can do so like this. Just row name and row number for whatever this dummy variable is here. So if you do that, it looks like this. And you don't even have to put this index in here if you don't want to. So let's say you wanted to get rid of the index here. You only care about the row. Then you can do like that. So let's say I want to add a 4th column to this data frame. And let's say we've got a few of these guys' ages now. So we've got df, and we're going to call it age, and we're going to assign that to this list here. So a bunch of integers and then one missing value here. We'll just call that numpy not a number. And then if we run this cell, and then look there, sure enough, we've got our 4th column. And similarly, we can also do that for rows. So let's say, hey, I've got a new observation here. So an 8th person we want to take a look at. There we go. Now we've got Bob. We don't have his favorite color, but we've got his number and we've got his age. And there's a way we can fill in these missing values here, and we'll get to that later. Say I've got 2 data frames that I want to vertically combine, and that they've got the same columns. So they both have name, color, number, and age in this instance. So there's my 2nd data frame. If I want to combine these 2 vertically, I'll just do pandas.concat. And then I'll put in a list here, the one I want on top and the one I want on bottom, if I can remember what the names are. Okay, so it looks like that. But we have a problem here with the way this is currently set up. If you look at these indices here, see that this index is repeated multiple times. So if I, for example, if I want the 0 index in this new data frame, I've got Timmy and Steve that I'm referring to. But if I want to refer to just Timmy, or just Steve, for example, then I would have to use iloc. So the first location there, instead of the 0 location. So if I do 0, oh my gosh, there we go, I get Timmy, and then it works out. But it's much easier on you if you combine them this way instead. You put this ignored index equals true, and then that'll basically reset the index. So now Timmy and Steve have their own indices, and everyone has a unique index, which is how it's supposed to be. Suppose now I want to replace all the colors in here that are blue and make them purple. So just do df.replace, and then put in what you want to replace, and then what you want to replace it with, and then the blues turn to purple. And this will change all the whole entries in the data frame. If you want to change substrings inside of there, you have to do something slightly different. So for example, if I want to change everywhere in this data frame that whenever I see Emmy, as in like Timmy or Jimmy, it'll change Emmy to Imbo. So we should theoretically get Timbo and Jimbo if we get this. We put regex equals true in there to specify that we want this to take place at the substring level. And sure enough, Timbo and Jimbo right there. So if I look at this data frame up here, I see these missing values here, and there's going to be times where we want to change those and make those something like a blank or a dash or a 0 or something like that. So if you want to do that, then all you have to do is just dataframe.fillNA and then put whatever the replacement character is that you want. So for example, if I want that to be a 0, I can do it as follows. And then I get a 0 here, and in here as well, but it looks a little weird, right? Because having a color be 0 or having an age be 0 doesn't really make a whole lot of sense. What might be better for the age here is to maybe replace it with the mean. And if we want to figure out what that mean is, we can just call the age column here and then put .mean at the end. It'll be this number. So then if we want to also replace the color with something like none, then we can actually make this a data frame as the input parameter, and then we can specify the filling at the column level. So we can say for the color, we'll fill that with none, and then for the age, we'll fill it with the mean that we previously calculated. And then let's make that our new data frame. So then we look here, and then sure enough, we have color is none here, and then the age is the mean that we'd calculated. But it looks a little awkward to have the age as a float, because nobody really goes around saying they're 30.85 years old, though I might start doing that. But if we want to make it an integer, we can just do dfage.round, and then we can make it an integer. And there we go. And then all we have to do is just reassign the age. Like so. So now I'm looking at this data frame, and I want to filter out the rows that fulfill certain conditions now. So let's say I want to find the rows in the data frame where the number is less than the age. So if I want to do that, I can say df, and then inside of these brackets here, specify df name, df number, less than the age. And we see we get indices 3 and 5 here. And sure enough, the rest of them, it's not lower, it's not less than. And it doesn't have to be based off of 2 columns here. Like for example, you can just say the data frame numbers such that they're less than 40, and you get all these guys. But you don't have to just limit this to numbers either. You can also look at substrings within the data frame. So if I want to find, for example, all the names in here that contain a lowercase ed, then I can say dfname.string.contains lowercase ed. And again, inside of these brackets with the df at the outside. And sure enough, we see all of these guys here. But we don't see the ed here because he starts with a capital ED. We can even look to see which colors contain at least one L in there if we want to do that for whatever reason. So if I do that, we can say dfcolor.string.count and then put the L there, greater than or equal to 1. And we get blue, yellow, and blue. And you can even put multiple conditions in here too. You don't have to specify just one. So for example, if I want to find all the rows such that the number is greater than 20 but the age is greater than 30 also, then I can do it this way. Notice I have these parentheses here surrounding each condition. That's because it's an order of operations issue. If you take them out, then it doesn't work. You get this error message here. So whenever you have multiple conditions in here, you have to surround them with parentheses. And you don't even have to have 2 conditions here. You can have 3 if you want. So we can also say, we can add a 3rd condition here and filter these down further and say, does the string name contain any? And we'll put an OR condition on there. So it's saying, is the number greater than 20 and the age greater than 30, or does the string name contain any? And it does, right there. Suppose we have a CSV of the Harry Potter characters and we want to load that into Python. Well, Pandas makes this super easy to load our data frames directly from CSV files. So all we would have to do is do pandas.readCSV, give it the file path, and there you go. So we've got character ID, character name, species, gender, etc. And we can use our knowledge gained from the previous section to answer some questions such as, who are the Slytherins inside of here whose wand core contains dragon heartstring? If I want to do that, we can use our complex query knowledge from before, say whose house is in Slytherin and whose wand core is dragon heartstring. We see that there are 4 people that fit that description: Slughorn, Umbridge, Bellatrix, and Lucius. And when we're looking at this CSV here, what if we find that we don't want to treat the first row as the header? This may be the case if you have a matrix of data that you saved, for example. It doesn't have a header, for example. So that's not a problem. All we have to do is read the function, read the CSV in here, but we'll say header equals none. And then there's no headers here. But then it's going to treat the first row as if it's data. And what if we want to skip the first 5 rows? So let's say these first 5 rows are really noisy or they're not relevant to the data. We can skip them. That's not a problem. So all we would have to do is put the skip rows equals n argument, and we'll just let n equal 5 in this case. And then it starts at the 5th row, or it starts at the 6th row actually here, because it's going to assume the 5th row is the header because we didn't put the skipped header clause in there. So if we say header equals none, then we start at the actual 5th row of data here. Now let's say I want to take my data frame of Gryffindors, for example, and then let's write that to a local file. So first, I'm going to make the Gryffindor data frame. Looks like that. And then we called it Griff df. We're going to do .2csv. And we'll give it the file path. And I'm also going to give it this other argument here, index equals false. So it's not going to print these indices here because I don't really care for those. They're not really adding anything to the data frame. There's going to be times where you want to keep it, but this isn't one of those times. And then I can read that same data frame or that same file back in, and we'll see our data frame pop back up. Just like that. And then we can also write that to a JSON as well. We don't have to write that to a CSV. So if you need to convert a data frame to a JSON, you would just do .2JSON. And you can also, you can even write this to a dictionary. I mean, that's not going to write it to a local file that'll keep it in memory, but it's a way to convert a data frame to a dictionary. So the way we'll do it sometimes is it'll be a dictionary to a data frame, but this way you can go backwards. There you go. Okay, so now let's talk about aggregating data within a series. So let's say I want to get some stats on the general dynamics of a specific column within the data frame. So for example, I want to know how the gender breaks down within the Gryffindor house. So according to this data set, I want to see how many males, females, or other non-specified genders we have here. So we have 21 males, 9 females, and 1 human. You can let people know that on the next trivia night you go to. And if we want to go back to the original data set, let's see how those houses break down. So getting another exercise in here with value counts, but this time we're going to set normalize equal to true, and that's going to give us a ratio. So that'll say that the Gryffindors are 41% of the book, Slytherins are 26%, 16% of the characters are Ravenclaws, and about 10% of them are Hufflepuffs, and 2% of each are other houses. And then you can also visualize this too. So what you would do here is at the end of value counts, you can do .plot.bar, and that'll give you a bar graph. And we chose the actual values here instead of the percentages. But if you want to do the percentages, you can do that too. And just say normalize equals true. And there you go. Okay, so now let's say I want to take the previous data that I had with the houses and divide that into equal bins. So we'll do 3 bins in this case. So I can use the pandas.cut function to do this. And if I use the default arguments here, I'm just going to get equally spaced bins. So if I do that, we see that the Hufflepuff and the other 2 houses here are in one bin, Slytherin and Ravenclaw are in another bin, and the Gryffindors are in their own separate bin, as they're by far the largest. But we can customize the bin edges here to make it and fit in some type of bin that we want to have. So we can do it like this. Instead of 3, you can specify your bin edges. So the first one starts at 1 and then goes from 1 to 7, 7 to 18, and then 18 all the way to 99. If we do that, that's going to give us a different configuration here. So now the bottom 2 houses are 1 to 7, Ravenclaw and Hufflepuff are in the 7 to 18 bin, and Gryffindor and Slytherin are in the 18 to 99 bin. But let's say I want to come up with different names for these bins, because I mean, I understand what's going on with these bins, but it might read a little easier if I call them, let's say, bottom third, middle third, and top third. So you can actually change these labels here as well by just setting the labels argument for however you want it. And it gives bottom third, middle third, top third. Alright, so now we're going to talk about aggregating data within a data frame. So I'm going to have a set of 2,000 individuals with the following data points: income, age, loan principal, and default history. So we're switching gears here. We've got a different data set this time. It's going to look like this. So we've got a client ID, income, age, and loan, and default history. It's just going to be a 0 or a 1. And if I want to take a look at this data to see if I see anything anomalous or something that needs cleaning, I'll just do .describe, and that'll give me a count, a mean, a standard deviation, min, quartiles, and a max. And there's two things I can notice immediately here that are a little weird. One, the minimum age here is negative, so that's a problem. And then also the count for the age is below the rest of the counts here, so there's missing a few values there. Also, this loan is really small, but it's technically possible, so I'm not going to worry about that one too much for the purposes of this exercise here. First thing I want to do is get rid of those missing values. So I'm going to do that, and we're down to 1,997 rows. And then I'm going to also get rid of the entries where the age is negative. That'll get us down to 1,994 rows. So we still have most of the data. It's mostly intact. And now I'm going to group this data by the default column. So group that have the 0 group and the 1 group, and then first I'll do the count for each of them, and that'll give me this. So 1711 and then 283. And then instead of the count, let's do the mean for each of those. So you can see that the loan balance for people with no default history is around 4,000. Median, the average age is 43. Average income is 45,000, and very similar income average for the people with the default history, but their age tends to be much younger, and the loan balance tends to be a lot higher. Yeah, so same thing as before. We're going to put it in the right cell this time under group by. And yeah, we get this. So now we can also say, let's say I want to analyze what happens when I look at ages that are less than 40 and whether they have a default history or not. And I want to see if there's some sort of predictor there or not. So I can create a confusion matrix here with the pandas.crosstab. So I've got a vector here that's going to be trues and falses, depending on whether the age is 40 or not, or is less than 40 or not, and then their respective default history. And when I do that, I get these values here. So whether the age is below, whether the age is less than 40 is false, and the default is 0, you get this. And if the age is greater than 40, is indeed less than 40, and the default is 0, there's 661 of those. So it's each combination of true false here and true false here. And we can get precision and recall from this metric. And if I want to do that, I'm just going to take the bottom right cell, the 283, and I'm going to divide that by the sum of all the trues here for the age. So that'll be around 29.9%. And then similarly for recall, we're going to do the same thing, except we're going to take this 283 and divide it by this column sum here, which is actually going to be 100%. All right, for this next section here, we're going to be looking at merging data frames. So you remember these zeros, 1, 2, and 3, and these numbers on the left-hand side here? We're going to be changing that now. That's going to be very important for when we're dealing with outer inner joins and left-right merges. So first, let's say we have these two data frames here, grades DF and majors DF. Now we got Sal, Joe, Q, and Mur. And we've got a grade just randomly assigned to each of them. I love all the jokers equally, so it's, you know, I didn't want to try to show favoritism there. And then we got majors. This set doesn't necessarily have to be a subset or a superset of this. It can just be like, we're going to have a couple of overlaps in there. We just want to at least have the same column name in both of them for one column at least. And then what we'll do for both of them is we're going to set the index equal to the name. So that's what they have in common here. So for grades DF, I'll do grades df.set index and the column name. So now that DF looks like that, and then we'll do the same thing for the majors data frame. And then that looks like that. And if you decide that you made a mistake, you actually want to reset this index, you can totally do that. So if you do that, you just get the same thing as you got before. Okay, so first off, looking at an inner join of these two data frames would be looking at what's the intersection of these two keys and what are the columns in each respective data frame. So for example, if I do this, grades DF, let's say I look at the grades data frame and I want to merge it with the majors data frame with using an inner join, then I'm looking at the intersection of the two keys here. And I'm going to be merging it on their name. So that's the index we're looking at here. And if I do that, we've got Joe and Q. And if you look back at each of these data frames, we see that Joe and Q are both in the grades DF and in the majors DF, with grade here and major here, and same with Q. But if we want to instead do an outer join, then we're going to be taking the union of those keys. So we're going to be looking at all the keys that are in both of them. And then if one's missing in one of the arrays, then you're just going to get a missing value. So when you do that, you'll see a bunch of not a numbers here. For example, Sal, he has a grade, but we never specified his major because Sal never appeared in the major data frame. And similarly, Phil, he never had a grade, but he had an applied math major in there. And now when we look at these left-right merges, we can take multiple tables of information and combine them, and we can answer more sophisticated questions under the implied assumption that the data is accurate. So going back to the Harry Potter cinematic universe, yes, I made that up, or so I thought, until I Googled it like a few seconds before recording this part of the video and found out other people had used that phrase, so. But anyway, how much of that Harry Potter cinematic universe takes place in Hogwarts, for example? If we're measuring time in terms of like how many speaking lines happen. So what are the 5 most common locations within the Harry Potter cinematic universe, and how many speaking lines is the word Horcruxes mentioned? So we're going to introduce 2 new data frames here, places data frame and a dialogue data frame. And with this dialogue data frame here, there were actually a few weird characters involved in here, a few like text characters. So I had to change the encoding up a little bit to make that read properly. So if we look at the places data frame, it'll look like this. It'll have a place ID, it'll have a place name, and a place category. And if we look at the dialogue data frame, let's do it here. You'll see a dialogue ID, chapter ID, place ID, character ID, and a dialogue here. So the actual dialogue itself. And you can see it starts from the very beginning of the first movie to the very end of the last movie. So we've got all 234 chapters. And each of these keys here, these IDs, are going to be used to thread these data frames inside of this one. So what we'll do is we'll first merge the dialogue and the places data frames. So the way we're going to do that is as follows. I'm going to do a merge from the dialogue data frame to the places data frame, and it'll be a left merge because we want to keep all the keys here because we're going to merge on place ID, I should say, sorry. So we're merging on place ID here, and we want to keep all of the ones that are on the left, and then whatever ones are on the right as well, we'll bring them over. So we've got all of the place IDs accounted for, so therefore we're going to have all of them come over. This shouldn't change the size in terms of the number of rows of this data frame. So when I do that, you'll see HP merged data frame is as follows. So now each of these place IDs has the associated place name and place category associated with it. Now if I look at the places data frame again, which I'll put it up here, we can confirm that. So for example, if I can get the index right, good grief. Nope. 7. There we go. So place ID 8 is going to be 4 Privet Drive, and we know that the movie starts at 4 Privet Drive. The scene with Dumbledore and with McGonagall. Okay, so then we're also going to take this merged data frame, and we're also going to merge the characters data frame that we analyzed way back in section 4. So we're going to use a similar process on that. And I'm going to just rename it. And then this time we're going to merge it on character ID since it's the characters data frame that we're merging. And then I'm going to sort the values of the dialogue ID. So that way it appears in order. So you can see here we've got a lot of columns on this now, and we don't really care about all of them. So we're going to condense this data frame. We're going to just keep 4 of these columns. Actually, I'm sorry, we're going to keep 5 of them. We're going to keep the dialogue ID, character name, place category, and the dialogue itself. I'm going to set the index equal to the dialogue ID here, because we're not going to be replacing that ID with anything. And it'll be a unique identifier for each line in the movie. So when I do that, you'll now see it as follows. We've got the character that said the line, the place in which it happened, the place category, and the dialogue itself. Okay, so now we're going to start answering some questions. Let's see, first off, one of our questions was how much of the movie took place in Hogwarts in terms of speaking lines. So if we want to figure that out, we go back to our value counts. And we're going to say normalize equals true because we want a ratio. And we see that about 60% of the movie happens in Hogwarts, which it checks out. You know, you see, especially in the first couple movies, it's a lot of Hogwarts, and there's a good amount of 4 Privet Drive as well. So that's one of the dwellings. So that's the place category, which is kind of a larger grouping of the locations here. If we want to do it at a smaller scale, we would say the place name. So if we wanted to get more specific with the locations, so you have the Great Hall is where about 7.5% of the movie takes place, and 4 Privet Drive should be up there as well. So sure enough, it's like the second most common specified location in the movies. And you can do the top 5 most common locations. As we wanted to mention earlier, we can just do this. I'm going to take off normalize equals true here and do that. So we've got the Great Hall has 557 lines, 347 lines are spoken at Fort Privet Drive, etc., etc. And then we also wanted to know how many lines in the movie contain the word Horcruxes. And one thing to note is that whenever Horcruxes are mentioned in the dialogue in this data frame, the word Horcruxes is always capitalized. Because if you try to do a lowercase Horcruxes, you get nothing. So we just do our .string.contains method that we had talked about earlier on the dialogue, and if we want an easier way to see exactly how many lines that is without manually counting, we just do .shape0 and we get 13. So the last section I wanted to talk about was data visualization within a data frame. So I'm going to look at a data set involving median weekly earnings, and I'm going to go ahead and clean it a little bit first, and then we'll look at the top 5 rows here just to kind of see what the data looks like. So we have a year, and we'll have a median weekly earnings. And now I'm just going to do a scatter plot of this. So we're going to do income df.plot.scatter, and we're going to specify the x and the y coordinates here. I'm going to specify a marker, so like the shape of the points on the scatter plot, and I'm going to give it a color. We'll say R for red. When I do that, I get something like this. And I can make it a line plot if I want to. So instead of scatter, we'll just put line. Let's say I want squares instead of triangles. Let's do S. And then instead of instead of red, let's make it green. We can do it like that. And this plot here seems to still be missing a title, so we can put a title in there. Most of the time when you give a plot to somebody, you want to give a title with it. So we can specify the title right here, year versus median weekly earnings, just like that. And sometimes you also want to label the y-axis as well. The x-axis is already labeled here. In this case, like it's pretty clear what the y-axis is, but we can just put a y label in there anyway, just to show you how to do it. You can just say y label equals whatever you want. So we'll say dollars for this instance. You can also even do a box plot too. So instead of a line plot, you can do that. So we'll just do the median weekly earnings column here. So this is just a series plot technically. Plot.box, and then specify the title, and we can make the color red if we want to. And sure enough, we get that. And there's other types of plots in here you can do as well. So this data may not be the best fit for some of those, but you can look on Google and you can see all sorts of different plots for stuff like that. But the general structure of it's going to be series or DataFrame.plot.something. And that's Pandas. So I hope you guys enjoyed it. I really enjoyed making this video. I hope that some of the stuff that I presented in this video can help you on your data science journey or just whatever you're doing using Pandas. And I hope to make a lot more of these types of videos where I can use my expertise in Python and in data science / math to help out the community. So if you liked the video, then just give me a like, give me a subscribe, give me a comment. You know, it's going to really help the channel out. I'm hoping to put a lot more of these videos out in the future. So every bit helps. Thanks, guys. I really appreciate it. Oh, and by the way, this video definitely did not come about in one take. There were a shitload of bloopers here, and if you guys are interested in looking at that, here they are. Hey, what's good, YouTube? Brian Jenkins here, data scientist. Going to be teaching you guys about Python. Fuck. Pandas. Not Python. Well, I mean, What the fuck is good? Oh fuck, I can't do that. Hey, what's good, YouTube? Brian Jenkins here. I'm a data scientist, and I'm going to teach you guys about Python. Fuck, not Python. Pandas. I'm going to teach about pandas. Okay, so now that I've got my my libraries in, fuck me. Let's say I want to add a column to this data frame. And furthermore, fuck, where'd it go? Damn it, that's a missing value. So that's the oh, what the fuck am I doing? But we want to vertically combine the two data frames. So, oh, that's a problem. Alright, suppose now I want to take my data frame that I've been shit. Then going to what? God damn it. And then we're going to look at the top 5 entries. Oh, well, that's not cool. So you could format this string a little differently. Have, if you want to call it a little differently here, what you can, fuck, it sounded stupid. And then like, I put the motherfucker in the wrong cell again, didn't I? Son of a bitch.